All right, welcome back, you fabulous math wizards of Virtual Room 502. Let's get started with problem 2 of the concept development. And it says explore commutativity. Say that like I say it. Commutativity, and say it all day long. Commutativity. It's a lot of fun. As it relates to multiplication. So you're going to be using your Avid agenda in the back there where you have the multiplication chart to help you out with this lesson. All right. So here's my fabulous multiplication chart. And if you were in class with me, you no doubt would have one of these. You would cherish it. You would be proud of it and take good care of it because it's going to show you the commutative property. And the problem we're going to look at first is 6 times 4. So don't need to write this down. If you have your Avid agenda and the multiplication table, it's not quite the same as mine. That's okay. Don't panic. It's all going to work out. We're going to look at 6 times 4. And how we're going to do this. And you can do it either way. You can go this way to 6 or this way to 6. Which way would you like to go? Okay, I didn't hear any of you say anything, so I'm going to make that decision. I'm going to go this way to 6, okay? Then I'm going to go, okay, it's 6 times 4. All right? Then I'm going to go, okay, 6 times 1 is 6. 6 times 0 is 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. What about 4 times 6? Because you see how they meet like that? What about 4 times 6? What about 4 times 6? I'm going to go ahead and write that up here because that's what I like to do. 4 times 6. What would 4 times 6 equal? If you know the commutative property, like I do, you'll know exactly what it equals. So we're going to go down to 4, and we're going to go across to 6. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And 4 times 6, ladies and gentlemen, boys and girls, damas y caballeros, look at that. They both equal 24. And that's the magic of the commutative property. Let's do another example of the commutative property. And this one is going to be, we've done that quite a bit. You know, this is always one that kind of gives us some problems, it seems like. Let's do 8 times 4. Okay, 8 times 4. And once again, we're going to start from this corner and go that way to the right. And I'm going to go, okay, here's 8. 8 times 0 is 0. 8 times 1 is 8. 8 times 2 happens to be 16. See, there's the 2, there's the 8. 8 times 3 is 24. And 8 times 4, it looks like it's 32. See how that works? 8, and we go across to 4. If you ever played the game of Battleship, and I strongly recommend it, it could really help you understand the multiplication chart. We used to play Battleship all the time, Dave Nadler and I. So it really got you used to going, okay, this way, in grids and whatnot. So if you have the game of Battleship at home, play it. It'll help you. So we have 32 here. 8 times 4 is 32. But what about 4 times 8? Will the commutative property work there? So I'm going to go down here to 4. 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. We already did that one. 4 times 7 is 28. And 4 times 8, look at that. The commutative property holds true once again. Nothing can stop the commutative property. Nothing at all. Let's try another one, and we're going to go a little shorter distance. We're going to do this. We're going to do 2 times 9. Are you ready to deal with 2 times 9? I know I am. We're going to go over to 2, but we have to go all the way down to 9. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 24. 2 times 8 is, is 16. And 2 times 9, look, 9 and 2 is 18. Let's see what 9 times 2 is. 9 times 2. What will that equal? We're going to go down 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go over 0, 1, and 2. And lo and behold, hot diggity dog, golly gee gumdrops, the commutative property has proven itself once again. People have questioned it through the ages, and it keeps proving itself true. You might as well accept the fact that the commutative property is always correct. And you can go ahead and play with this at home. So okay, 5 times 6 is 30. 6 times 5 is 30. Huh? 7 times 7 is 49. 7 times 7 is 49. That wasn't a very good example. Let's do 7 times 6 is 42, and 6 times 7 is 42. It's all about the commutative property. And I'm sure Prince Yvonne will come on here one day and mock me for saying commutative property the way I do. But you know what? I'm okay with that. If she wants to be that way, I say let her be. Let her be. Now, what I'd like you, fabulous third graders, math wizards of room 502, that's virtual room 502, what I'd like you to do is gather up your Module 3 problem set and Module 3 homework book, because you're going to need those for the next couple of weeks. It's just the way it goes. It's almost as true as the commutative property.